Hello there. This morning I woke up and my wife asked me which colour exercise band should I use. She was doing this exercise right here. She stood on the band holding the elastic. It was yellow. And then she was rotating the arm like this. What a good question. There's actually a bonus question here for those who've done or are doing A-level maths. How much work done through one repetition of this, from the initial position to the highest position, and you can assume that the original length is 1. Before I go further, just a disclaimer, this is not a medical advice, this is just a bit of maths. So we actually need to simplify the problem first, because in this first one, as the arm is rotating around the force, the geometry is slightly changing, and so the force is a bit more complicated to calculate. So let's simplify. Let's just assume we've tied the elastic band, the therapy band, the exercise band, to the wall or door handle, and we are just pulling on it like so. And you would know from experience, when the band is slack, it's no force, but as you pull on it, it gets more and more difficult. And there's a formula for this. Force is related to is lambda x over L, where x is the extension. So if the band had a natural length L, and you extend it by however much, you get how much force. So lambda times x divided by L. So if you double the extension, it will pull back twice as hard. Good. So what does this look like on a graph? So it's going to look something like this. As when the band is slack, I have no force, and when I pull on it, I'm going to get some force, and it's going to be a straight line. And if this was a spring, just as an extension here, if this was a spring, well then that's going to go negative, because as I push to the left here, the spring is going to resist me pushing in. So this straight line here, the gradient of this straight line is going to be lambda, because we've decided on our length. Actually, the gradient should be lambda over L. Okay, but if the length is fixed, then it's going to be lambda, proportional to lambda. So does it matter what color band you use, the red one, the yellow one? Well, yeah, yes and no. If you have no choice in the length, the only thing that you can vary is the stiffness of the band, then yes, it does matter. But if you can choose the length, if you can choose how far to tie this off, okay, then you can control the stiffness that way. Let's just demonstrate that. So for instance, if you had the same band and you started with you tied it off shorter, and you started here with your arm, and you started pulling like this, well, this is going to give you a much tougher workout. Okay, let's run through the math, see what's happening. Well, you've halved the length, so this is now half as small. So if the denominator is half, so half as big. If the denominator is half, then that means your force is going to be twice as big. You can try this at home if you have a therapy band. You tie it off shorter, you pull the same displacement here, you're pulling the same amount, then yes, you will feel that this is much stiffer. So you can control the stiffness by changing the length of the band. And that's very easy, because usually the bands come in rolls, and your physio will probably cut you off quite a big bit anyway. So why do we need different color bands? Okay, if you can control it doing this. Well, the reason is sometimes you can't change the length. Okay, so for instance, there's an exercise that looks like this, where your arms are by your side, and you're holding the band like so. And then you raise your arms on both sides. So your arms are now stretched out here. Okay, and so the band is stretched to this length. Okay. Well, you can't change this length. You know, if your arms are by your side, you can't change that distance. That's just where you start. And so in this situation, you have to get the correct color of band, thickness of band. There is still a way to cheat this one actually. If you need more stiffness, what you could do, you could double up the band. Okay, so you could fold your band in half. Okay, and you hold two bands together basically, like so. Okay, you hold them together. This will get you twice the stiffness. Let's say you don't want that much, you just want a little bit more, but not too much. Then I guess you could cheat. You could tie a band so that it joins together somewhere along that way there. So you can still actually sort of improvise your way out of this if you're willing to do this calculation. I mean, these calculations get a bit annoying now because you've got two strings, and this one has twice the stiffness. You can see where this is going. If I really needed to get this accurate, I can have different profiles here. Where were we? Okay, right. Okay, let's just go back to reality a bit more. We assumed something here. We assumed that at full arm extension there is no load. Now, in reality, you wouldn't do this. This is very light exercise. I guess if you're injured and you're rehabilitating perhaps, but if you're trying to build strength, this is not going to do much. You usually start. There's already a bit of load, so we wouldn't start the graph at 0 here. Let's draw a fresh one. Okay, so we're going to start the pull at 100 newtons, about 10 kilograms, and we're going to, when we're all the way in, we want to be around 15 kilos, 150 newtons. So I'm assuming my arm pull has got 60 centimeters of travel, 0.6 meters. Let's say you're actually thinking, yeah, if I can solve this problem, then why would I need weights? Maybe I can do everything with resistance bands. Well, we're going to work through this and see why we might still need weights. So let's see this. What do we have? Let's get back to a formula again. Lambda x over L is force. So the gradient of this line is going to be lambda over L. And we know gradient is rise over run, so there's 50 divided by 0.6. That comes out to, I think, around 83. Around 83. Okay, so if I have a stiff band, I'd use, if my lambda is bigger, I need to use a longer piece. If I have a piece which is not very stiff, so low lambda, I need to have a correspondingly shorter piece. Okay, so I want to stretch a shorter piece, and then that'll give me more stiffness. Okay, so let's just see what this looks like. So this is not entirely to scale, but let's see. If I was to extend this graph, okay, then when it gets to 0, when f gets to 0, it's 1.2. So another. So my exercise band has to extend all the way back here. So at this point is when it would have had no force, and of course it still has its own length. Okay, so let's just say the length is up to there. Okay, so this is my wall. Okay, so let's call this one the stiffer band. Stiff. If I have something which is less stiff, then I would need to be a bit closer. This would be a bit shorter. To begin with. Now, this part here to the left, everything left of this 1.2, this is not to scale. It depends on the actual material properties, but what you realize is that with different stiffness bands, you need to be your start point needs to be a different distance away from the where you tied it off. And practically speaking, this might be difficult to achieve because you might stretch the band so far. The band will probably break because you've stretched it so hard, or it will start to not behave in a linear, in a straight line fashion. So then all of this modelling goes out the window. Now, if you were to use weights with a pulley, then this is what you'd get. You'd have the weight hanging over here, the cable, and as you pull, well, this weight just goes up and down. It will give you a constant force of 150. Obviously, you've got to put 15 kilograms here. It will give you around 150 newtons, and you'll be going back and forth along this line here as you're pulling. This is X in meters. This is different to if you were doing it with a band. With a band, as you're pulling up, you're going along here, but as you come down, it's slightly lower, okay, ever so slightly, because the band is heating up. There's a bit of hysteresis, a bit of energy loss. But for the purpose of exercise and strengthening, it doesn't really matter too much. So now that I've done some maths exercise, I might go and do some real exercise.